Hello friends, dear students. In the previous video lectures, we have discussed some prerequisite of Fourier series. In these continuations, we are taking some important points, in which one is finite number of discontinuities. At +2 standard, we have discussed what is a continuous function. Of course, we know, everyone knows about the continuous function at a point in a domain, as well as discontinuity of a function. You all remember what do you mean by discontinuity? Means if a function is not continuous at a point or in its domain, then the function is known as discontinuous. We have already read types of discontinuity. There are some different types of discontinuity. One is removable, non-removable. In this category, an important type of discontinuity is finite number of discontinuity. Now we are taking this concept. What do you mean by the finite number of discontinuity? Means if in a function at a point left hand and right hand limits exist, please keep in mind exist, but not equal. No, there is a slightly difference between removable and finite number of discontinuity. Removable in also left hand and right hand limit exist, but in that case both limits are equal but not equal to the function value at a given point. But in that case both limits exist but not equal, exist finitely also. So that is called a finite number of discontinuity. Now consider an example, please. Tan inverse 1 upon x. If you are interested, its limits, its continuity at x equal to 0. If you are interested, the continuity of that function at x equal to 0. So as usual procedures we have already discussed in class 12. First of all, we will calculate its left hand limits. X equal to 0, the left hand limit of this function is minus pi by 2. Right hand limit of this function is pi by 2, which shows that both limits exist finitely but not equal. Therefore, this point is a finite discontinuity for this function. Next, any doubts? Okay. Next term, mathematical terms, piecewise continuous functions. We have read so many questions at +2 levels in continuity and differentiability topics. What do you mean by? Now again repeat it please carefully. A function which is defined in an interval, if we broke this interval into finite number of subintervals and the function is continuous in each and every subinterval, then the function is called piecewise continuous function. For example, we are taking this example. F of x is defined in the interval -1 to 1, and that open interval divided into sub 3 intervals. One is when x is less than equal to -1. F of x is a function which is defined in an interval -infinity to infinity. Change please, -infinity to infinity. Divide this interval into 3 subintervals. One is when x is less than equal to -1, its function value is this one. since this is a polynomial and characteristics is polynomial is what? Always continuous in their domain. Yes, this is continuous. When x between -1 to 1, the value is 1, which is a constant function, is again continuous. And in third subintervals, for x is greater than or equal to 1, this is again a polynomial which also continuous in that interval. Which also we can show this example by this figure. This is the first subinterval less than -1, and the graph of the function is this one, a straight line. In the second interval between -1 to 1, it's a constant value. In the third interval, it's a parabola. It means that function is continuous piecewise. I hope all of you have a fair idea about piecewise continuous function. And third one is what? Finite number of maxima and minima. Finite number of maxima and minima. All we are aware about the maxima and minima at +2 level, +2 standard. What do you mean by finite number of intervals? Let's discuss, please. If a function have finite number of point of maxima and minima in their one period or in the given open interval, then the function has finite number of maxima and minima, which is shown with the help of the very common function, sin x. If we draw its graph in the interval 0 to 2 pi, we can see that what? At pi by 2, it's at maximum value 1. It means pi by 2 is a point of maxima. And 3 pi by 2, it has what? Its minima value -1. It means x is equal to 3 by 2. Its point of minima in which interval? In the interval 0 to 2 pi. It's a one period. Similarly, it can repeat its the values from 2 pi to 4 pi, but we are focused on in one interval, in one period. The sine function has one point of maxima and sine function has one point of minima. That is the meaning of finite number of maxima and minima. Now, in the next topic, very important. What is the meaning of even function and odd function? It's a very simple concept which we have discussed in class 12th and first semester level. Here we will define even and odd functions algebraically as well as graphically, geometrically. Algebraically, graphically. Algebraically, what will we do? Replace x by minus x. Say function is y is equal to f of x. Replace x by minus x in the given function f of x. क्या होता है? Okay, let's see. if there is no change in the function always and even, if function is minus one time of its original value, the function is odd, is called an odd function. This is known as the algebraic method. Graphically, we can identify the nature of the function, whether it is even or odd, with the help of symmetry. If a function is symmetrical about x-axis, about y-axis, then function always an even function. If symmetrical about origin, then function always is known as an odd function. Now, consider an example. This is a graph of parabola y is equal to x square. If you replace x by minus x in that function, due to its even power, function will remain same. Therefore, by algebraic method, the function is an even function. Is that clear? Now, symmetry. That function is symmetrical about y-axis. Means y-axis works as a mirror in that case. Therefore, the function is also what? Graphically, the function is what? An even function. And let's consider sine function. Please check it. If we consider y is equal to sine x in the interval minus pi to pi, how to check its nature? First, algebraic method, we want to check its nature. If we replace x by minus x in that interval, what is sine of minus theta? Minus sine theta. Therefore it is what? An odd function. This is an algebraic procedure. Now, if its graph is given, now how to identify whether this function is even or odd? Please look at the graph between minus pi to pi is symmetrical about origin. Symmetrical about origin. And this symmetry shows that the function is an odd function. This function is an odd function. This is a very simple concept. I am taking again one more example. We are discussing a very important example. its graph is. Now please check it. Check it. This is called a waveform. The graph of this function is what? From minus pi to pi is that one. Now, this graph clearly shows what? What shows? Clearly shows is symmetrical about y-axis. This is the axis of symmetry. Therefore, function is even. Now, this is its graphical representation. Now, how to prove algebraically this function is an even or odd? Now, replace x by minus x. We get what? Everywhere where x is written, we should replace x by minus x. Everywhere where x is written, please be careful. We further simplify this function, plus minus minus, so we can write it 2 pi by x. Okay, here the range is what? For what? Minus x, but in the initial function the range is for what? X. So we should multiply both sides of this inequality by minus sign. We already know that. If we multiply an inequality by a minus sign, then inequality will always be reversed. If we multiply by minus sign, please look at here, minus sign to this or this, then we can write this inequality like that. And similarly, here again, minus minus plus, and again apply the same concept. Now here is pi. Multiply this inequality by minus sign to the both sides. We get what? Now, after replacing x by minus x, we will get this output. Now check whether this output is the same as the original one or there is a change. No, we found that that output is equal to its function value. Therefore, it means the function is n what? EP. This is also an important concept in Fourier series. Many questions will need to check whether the function is an odd or even algebraically as well as graphically. Thank you very much, friends. In next lectures, definitely we will discuss some important topics in a very simple manner. Thank you very much.